Hi, hello, good morning, everyone. What a very beautiful day, very warm today, sunny. Maybe before I start, I just want to check if everyone can hear me or not. Maybe say yes in the Zoom chat. Good morning, everyone. Hello. Okay, so I assume that everyone can hear me clearly. Then I will start the lecture now. This is weekend already. Time flies very fast. Welcome everyone to Fit to 107 Software Quality and Testing. And today we're going to talk about code quality, technical debt, and static analysis. What does it mean? How should we do that? And how can we detect it? Okay. Okay, so before I start, I just want to emphasize one thing that normally, as I mentioned before in the past few weeks, that most of the time software defects are discovered at the no, sorry, they are normally introduced at the early stage of the software development, for example, from the requirement phase, but they are detected at the late the last part of the software development, for example, during the testing or during the release, right? But the issue is that when we try to fix such kind of bugs at the end of the software development process, the cost of fixing them are really expensive, right? Like as you can see in this figure, at the beginning, during the conception, the design, and the development, the cost of the fixing software bugs, they are very cheap. But when it becomes the testing phase or the release phase, it is getting more expensive. Okay, so that's why we try to avoid such kind of software defects as much as possible, right? But then why? How should we do that? Okay. Before we delve deeper into this kind of concept, how can we improve? How can we reduce the software defects, or how can we improve the quality of the code? There are two terminologies that I would like to introduce here and try to clearly distinguish what is the difference, right? In this slide, we talk about the code quality and the software quality. They are interrelated, but actually they are different. Okay. So what I mean is that as you in the first bullet, right? Software quality and the code quality can coexist. You can write quality code that is compilable, that is executable, that is aligned with the customer requirement, user requirement, and then you can produce like high quality software. But it cannot imply the other way around. Okay, high quality software cannot be like cannot be produced from the poor quality code. Okay, but if you develop a high quality code, then you can produce the high quality software piece of software. Okay. So that means, but what does it mean by definition, by in general, right? Like what does it mean by good quality code? So we want to make sure that when you write the software, when you write the code, it is readable, it is maintainable, it is portable, right? When in the first few weeks, we talk about the quality, software quality attributes, but that one is for the whole software products, whether it is reliable or not, whether the functionality is correct or not, whether it is what is that? What else? Whether it is usable or not. Talk about the usability, that kind of thing. That's a whole high level of the software products, but the high level of the software products cannot be of high quality if we don't look at the code itself, right? That's the heart of the piece of software. So that's why when we talk about the code quality, it's not just only the bugs, but we are talking about maintainability as well, when and whether it is extensible or not, right? It's about how do we design the software, and it's not just only the code, but we should also look at the test code as well, right? When we implement when we do the unit testing in the first few weeks, as you remember, we have the software requirement, we implement some Python file, and then we also need to implement the test file as well, right? So, but the test file or the code, Python code, uh, it can be poor quality as well if we don't make it readable, that kind of thing. Okay, so that's why code quality is very important, especially for the enterprise software system, right? Because let's think about the when we develop the piece of software for a 1 year project, right? We just develop it, but it's not like a one-off software development. We need to maintain it. We want to make sure that this piece of software that is developed once, but it is used like for the next few years. That's why we need to ensure that the software that we develop that we develop is maintainable as well. Okay, otherwise with the code, right, poor code quality, software dies early. Yeah, so we don't want to develop something that is not maintainable. If there is a bug, someone jump in and like new person jump in and they cannot fix anything, right? That then the software is dead and it is very costly. It is very time consuming. Why do we develop such kind of software, right? But let's imagine, let's think about, can you give me some names? What is the software that has been used like more than 5 years, 10 years? Can you imagine about that? Yeah. Maybe can you type in the Zoom chat? That kind of thing can be some good indicator of like that piece of software is designed really well, right? Yeah, that's right. Microsoft Office, right? Ubuntu, Microsoft Windows, okay? From like a Windows 95 and right now Windows 10 already. That's right. So yeah, this kind of software has been designed really well. It is maintainable, you know, and the last part of the slide here, right? Why the code quality is very important, because it will make software very robust. It can increase the readability. Someone can modify it easily as well with the proper comments, proper indentation, coding style up to the standard. You know, clear notation, simplicity, easy to understand. That's why this kind of thing that is very good, right? And then it can decrease the technical debt as well. We will talk about it later as well. What does it mean by technical debt? Okay, yeah. But then when the software, the code quality is not good, right? There are three main types of the code quality issues. Three main, okay? There are other types as well. First is the bug. This is everyone understand, okay? It's a coding mistake that can lead to an error or unexpected behavior at runtime. You work on the assignment one before, you try to pass the test case, but sometimes, you know, you got some bugs, you cannot fix them, which is totally fine, right? Not totally fine. I should not say that, but I mean, it is typical, right? Everyone can have bugs. And then another type is the vulnerability. When you have a high quality of the code, you don't have any bugs, but sometimes the code can be vulnerable to the attack as well. That means cyber criminals, like hackers can hack into the system easily, right? So it really, this is the second types of the code quality issues. And the last one is the code smell. Code smell is related to the maintainability of the software system now. For example, when you write some code that is very spaghetti, it's not understandable at all. There are lots of duplication inside the code. The code is highly coupled together. It's not maintainable, that kind of thing. That's the code smell, right? And when in the real world software system, okay, if you work in a software company, because in reality, there are bugs happening every day, right? Every minute, every hours, but we need to prioritize them. Whether that kind of bug is a critical one, it is a blocker, it is the most severe one or not, or this is something like just a minor one, right? So that's why in open source software system, they often use these 5 severity levels. Okay, first, the blocker is the highest critical one, and then that means, for example, memory leak, right? We indicate this one as a blocker because no one can use the software at all if there's a memory leak problem, right? And critical, it is also have an impact on the behavior of the application as well. An example could be, for example, what is this? SQL injection, right? So when SQL injection is some type of the vulnerability as well, and it is quite critical because someone can hack into the system. Why it is not a blocker? Because whether if the software has an SQL injection issues, whether the software is still usable or not, yes, but it's not like the blocker, right? So normally people can still use a software, but the software has vulnerability that the attackers or some hackers can hack into the system. So that's why it is critical, but it's not the blocker. All right. Okay, major is the bug that can impact developers productivity as well. If it is impact the productivity a lot, that's the major types of the bugs. Otherwise it is a minor, or if they are not the bugs at all, people normally we just indicate it as an info, right? Okay. These are the bugs, okay? But if we use like a Jira issue report tracking, bug tracking system, that kind of thing, there are two types as well, okay? The new feature or the bug, all right? That's when we create the issue. Find the issue, new feature, that's the other type. We are talking about the bugs here, okay? Don't get confused. All right, now the next topic is that how to check the code quality. How can we detect it? Of course, we will talk about the code review as well, right? Pair programming, use human, manual, right? But it is time consuming. How can we automatically detect the code quality issues? One of the tools that people often use is called static analysis, static code analysis tools. What is the difference between the static and the dynamic analysis, right? Okay, so these are the tools that they implement the rules, the template, based on the patterns. This is not the right way of writing. They don't execute it. They just pass the program with the abstract syntaxes, data flow or whatever, and they try to match with the rules or the patterns behind the system, behind the tools. Okay, so when we use this kind of tools, the tools just analyze the code statically. They don't execute it, okay, statically. Look at the code, look at the flow, look at the abstract syntax tree. They often use to detect the, what is that? For example, programming errors, okay, coding standard violations, undefined values, syntax violations, security vulnerabilities. These are based on, again, patterns, okay, based on the patterns. I will just give an example, right? Undefined values, probably this is the easiest one. When you write the code, okay, you want to return X, okay, return X, but X is not defined yet. That's the undefined values. When you pass the program, okay, pass the Python code into the abstract syntax tree, you can develop some algorithm to detect it easily as well, whether each of the variables in the program has been defined or not, right? Okay, this is an example of the static analysis. Or the security vulnerabilities, we will talk about that later as well. For example, SQL injection, how can we avoid using the username and the password in the code? How can we blind it? How can we hide it? That kind of thing. Okay. There are so many tools, okay? Many static analysis tools. You can check into the GitHub link this one as well. For example, in the Python, there are these two, right? AutoFlake, AutoPep8, Bandit, PyAnalyze, PyLint, PyType, and Radon. For the Java, there are tools like CK, Psychometric Complexity, CK, Dupe, Error Prone, Check Style, Spot Bug, Firebugs, or C and C++, Flaw Finder, Clee, CSOUT, and AI Bug Hunter as well. Okay. The benefits of the static code analysis, right? Because normally when we do the code review, okay, we will talk about that which week, probably in the next few weeks. It is quite time consuming. It requires manual, people have to look at it. But when we use the static analysis, code analysis, right, that's much faster because it's a tool, it is automated. And it is scalable as well. Let's say if you have like 1,000 billion lines of code, 100 million lines of code. That's quite a lot, right? If you require human to manually look at it, it's too time consuming. So that's why we need to use this kind of tool to help developers detect the code quality issues at the scale. And yeah, it's not required the tool operator to have the same levels of expertise as a human auditor as well. When you require code, when you do the code review, that code reviewer should be an expert in that area, right? But in reality, not everyone is an expert in, let's say, if you want to develop the Wi-Fi module in the Android mobile application, that kind of thing. Not everyone is an expert, so it's hard. That's why this kind of tool is quite helpful in this context as well. You don't need to hire like extremely expert developers to look into the code, right? Okay, but I would like to emphasize again that static code analysis often look at the code structure. Okay, it doesn't look at the functionality of the software system. Make sense? That the functionality part still requires human, right? Because only human understand the requirement, translate into the code, right? Implement the functionality of the software system. The static code analysis only look at the code structure, look at the maintainability aspect, look at the security aspect based on the template. So these are some of the limitations as well. It's not the, like one silver bullet, you know? Okay. All right. Yeah. But what makes a good static analysis tool, right? First, it should be easy to use. It must be understandable by the general developers as well. It's not like too the bugs that they discover is not too specific. It must be explainable. It must be justifiable. What does it mean as well? And it would be great if the tool can suggest how to fix them as well, right? Yeah. So what to consider when using the static analysis tools? Normally, it requires a human evaluation as well. When you use the tools, you should not like solely rely on the tool, trust everything. Sometimes the tools can generate false alarm as well, false positive, you know. That means the bug was discovered where it should not be the bug, something like that, you know. No, sorry, false positive or false negative. Yeah, for example, the program contains the bug that the tool does not report, right? This is the false negative, they cannot find it. Or the false positive, the tool report the bugs that the program does not contain. So we should not like 100% solely rely on it. We still need human expert to judge whether this is the right bug or not. Okay. Right. And because there are lots of limitation here, right? With the static analysis tool, it is based on the pattern. They cannot cope up with the new patterns of the bug, of the code smell, of the vulnerabilities, you know. Like in reality, there are million types of vulnerabilities. How can we develop like capture everything? It's impossible. That's why nowadays people often use the AI, okay, artificial intelligence on the machine learning to develop this kind of technique as well. Think about, I'm sure everyone knows the GitHub Copilot, okay? You have tried it before. So they build a machine learning model, build the AI models, okay, based on the large code base, and then to come up with what are the patterns of the, for example, the bugs, vulnerabilities, how to detect them, that kind of thing, right? So this is one of the examples of the tools that one of my PhD students developed it as well. It's called AI Bug Hunter. It is integrated into the VS Code extension at the moment. Basically, this tool is able to, is for C or C++ program. It can detect, locate, explain, and suggest corrections in real time as well. Everything is based on the large language model, okay? For example, right? Let's say if you are a developer and then you write this piece of code, okay? This is a C program. And then if this method is vulnerable, right? The tool will generate the warning, the alarms immediately by the AI bug hunter here and tell you exactly which line, okay, which line actually cause vulnerability and how severe it is, okay, what type of the vulnerability as well. Normally we use the CWE number to describe the type of the vulnerabilities, okay, and this is another technical detail as well. What is the type, okay, and this tool can also suggest fix as well, right? If you click the button quick fix number 5 here, it will tell you how to fix this vulnerable code, okay, and this is another explanation as well. What does it mean by out of bound, right? Okay, so it means that the software write the data past the end or before the beginning of the intent buffer, that kind of thing. Okay, I will not go into the technical detail, but I just want to say that when the this kind of advanced technique, right, we learn from million GitHub repositories and with a large numbers of vulnerable patterns as well, so the tool can correctly detect vulnerability at the large scale with the up-to-date patterns as well. Okay, this is an example. Yeah, but again, the AI tool, that one, AI Bug Hunter, is still a part of the static analysis tool, but we just don't rely on the patterns, but we rely on the AI or the machine learning model to let them automatically learn the patterns by itself, okay? So if you are interested in more details, please feel free to reach out to me as well, okay? But there are some limitations, right? Passing static code analysis doesn't prove that your code is safe, but failing it pretty much signal it isn't, okay? So that means when you use the static code analysis tool, it's just a quality gate. But it doesn't mean that when you pass it, everything is all right, right? If you remember the DISTAR code before, testing only prove the presence of defects, but not the absence. Okay, do you know? Okay, does it make sense? Yeah, but if you fail to use it, I'm sure there are some issues with the code quality, definitely. Okay, yeah, so that's the static analysis tool, and this is more like a enterprise products as well, enterprise level of the tools. It's called SonarQube. It is widely used in the software companies, software organization at Monash University, Monash eSolution. Everyone use it, SonarQube. Okay, so normally the tool is you have to install at your system and indicate which repository that you want the tool to analyze, and it will tell you, okay, this is basically a summary. The tool will tell you how many reliability issues, okay, how many security issues, how many maintainability issues. Look, these are the 3 aspects that I mentioned before, right? How many bugs, whether the code is secure or not. Is it reliable? Is it secure? Is it maintainable, right? And when you look at the maintainability, we often look at 2 types of issues inside here. First one is a technical debt, and another one is a code smell. I will talk about that later. All right. So if you use this tool, it will tell you the high level. Okay, this is a summary. But if you dive into the details, right? The tool will tell you. For example, if the tool detect the bugs, what does it mean? Let's say this is, I believe this is a Java, okay? Java program. Public void inject message, something. And then the tool will generate the warning here that this is a null pointer exception, could be thrown, get filter can return now, blah, blah, blah. This is a bug. It predicts that this is a major type, and it has a feature whether you want to open this issue or not, right? Create a bug report, and whether you want to assign it to someone else to fix it or not. And surprisingly, it tells you how much effort it is required to fix this bug as well. Looks like it's a 10 minutes effort. Wow, very good, very smart. Okay. So on the right side, it tells you at the line level, right? Which line cause bugs. But on the left side, it is pretty much tell you a summary of the whole file. For example, this is the whole file ActiveMQ system. And what are the issues inside this file? This is an example of the bugs, okay, in real world. What about code smell? Code smell, okay? Code smell, as I mentioned before, code smell is pretty much about the maintainability issues, right? So by definition, code smells are methods, functions, or classes that violate the principles of the good OO design, object-oriented. For example, clearly define single responsibility, encapsulation, information hiding, field and clear interfaces, proper use of inheritance. These are more about object-oriented now. Clearly define single responsibility. Probably this is the easiest one to understand. Let me give you an example, right? For example, if you create a method, if you think about the assignment one, okay, we have a unit method, okay, unit level, unit function, and each of the function serve only one purpose. Make sense? And with the clear input parameters, that kind of thing. But let's imagine that you have like one big function, define, main, and you combine everything together. First, it's very hard to test. It's very hard to write the unit test as well. The testing becomes even more difficult and is hard to maintain. Let's say if you want to implement a new function, let's say discount coupon, right? Then you have no idea how to extend it at all. So that's why that becomes very difficult, right? That's another type of the code smell, okay? So when you use this kind of tool, it can detect some high level maintainability issues, okay, based on the patterns. And it can also find security vulnerability as well. For example, it tells you that this is a vulnerability type. It is quite critical whether you want to open it or not. Who do you want to assign? And how much effort do you need to fix them, right? And it also provides a link to the reference as well. Probably because this is these kind of bugs are detected based on the patterns, right? That's why it can link to this one as well. Probably this link CWE OWASP A3, this one gives you a template or an example of whatever happened, what the past vulnerabilities, the known one, okay, in the past. So that's why this piece of code are quite similar to that one. That's why they the tool detect this one and indicate it as vulnerable, okay? Yeah. And it's not just only detect it, right? It can enforce the security best practices as well. Let's say if you want to generate the key, encryption key, and you can use this kind of bit, right? 1024 bits for the encryption, but it is outdated already. If you set the encryption policy to be 2048, with this is the at least, then the tool can detect it as well. Whenever you say key pair gen.initialize, if the value here is lower than whatever it is defined in the policy, right? Then you can detect it as well automatically, whether the code is up to the standard or not, right? Okay, that is really useful, really helpful. Yeah. Okay, but it's not just only the detect, right? Another concept that you should know is called technical debt. It means that it is the code quality issues that you actually know. What are they? It is the bug, it is the issues, but you don't fix it. It's called technical debt because technical, right? It's technical debt. It's not the real financial debt because you know it, but you don't fix it. That means later on, when you deploy it, you want to go back and maintain. You still need to fix them anyway. So that's the debt to yourself. That's a technical debt. Okay. Yeah. And so basically, technical debt is a gap between how to make the change perfectly, how to make the change perfect, or making the change work, right? That means I'll try to uh, explain this one first. Okay, let's say if you are a developer and you know that these are the issues, right? And then how can I say, these are the issues, but the manager tells you that, okay, tomorrow we need to release the software now. What should we do, right? So your time is quite limited. You may not have the time to make the change perfectly. But if you do, it means that if you want to fix everything, right? There are lots of effort. That means you need to preserve the architectural design, preserve it, employ the good programming practices and the standard, right? This is a bug. You want to preserve it. You want to make your code up to the standard, update the documentation, test the code roughly. It takes a lot of time and the effort, right? Or instead of doing this, you can also make the change work as well. So that means this is like a dirty thing, you know. If you find bugs, you can just fix something quickly as possible with a few resources as possible as well. But I would say that technical debt is a gap, right? When you do something quick, probably you come back and you need to refix it as well. So it really depends. This is something in between, whether you want to make it perfect or you want to make it workable, okay? And what are the technical debts, right? For example, issues not linked to the code-based knowledge stuck in engineering head. No, okay, this is the red flags. Okay, when what are the typical causes of the technical debt? This is the technical debt often start to happen when this thing happen, right? For example, when you have a huge backlog. You have a lot of tasks to do, but you cannot do everything. You can just what? Okay, make something quick. Okay, do something, make it quick, make it work as soon as possible. You don't discuss the backlog regularly. You don't have a stand-up meeting with your team. Then there's a sign of introducing the technical debt. Okay. Engineers rarely view issues. Okay, there are lots of bugs. There are 100 issues in the issue tracking system. No one take a look at it, and then you just keep developing it, right? And what does it mean? It means that these issues are overlooked. No one take a look at it, and then you just develop something. Later on, if you want to fix these issues, maybe you need to rework for everything, right? Engineers rarely create issues. You know issues, but you don't create it. No one will know it. And then later on, if you found it, then the cost of fixing them is really expensive. Okay. Code-based knowledge stuck in engineer heads. Okay. It means that everything you know is in your head. You don't document it in the documentation, then no one will know it. Then how can we share the knowledge? And not every engineers will be on the same page, right? Issues not linked to the code. You have the code, you have the issues, but this is the issue to where? To which file? To which module? No one knows. That's a sign of technical debt as well. Okay. Yeah. So this is a sign of the technical debt. And there are some indicators as well. Let's say you have a discussion with your peers, okay? And then let's say if managers tell you that, okay, don't worry about the documentation for now. Let's try to get something work as soon as possible. That's another indicator of the technical debt now, okay? Or the only one who can change this code is Peter, okay? That means the whole code base, this piece of code is heavily rely on Peter. Without Peter, no one can fix it. That's a sign of technical debt as well. Or it's okay for now, but we will refactor it later. Okay, that's okay. Let's get it done. We will refactor later. That's a sign of technical debt as well, right? When you write the code in the comment, okay, doc string, and you put the comment here. To do, fix me. This should be fixed before release. But if you don't fix it now, you will never fix it. Okay, that's the common practice. So this is another side of the technical debt as well, right? Let's just copy and paste this part. Okay, paste, yeah, should be paste. Yeah. let's uh, let's just copy and paste this part. Okay, that's a duplication. Code duplication, that's a sign of technical debt. Does anybody know where we store the database access password? That means the documentation is very poor, right? It's not a good practice in this team. I know if I touch the code, everything else break. That means the code is highly dependent. There are too many dependencies in the code. That's not good as well. Let's finish the testing in the next release. Oh dear. Okay, we will not test anything in this release. We're gonna test in the next release. That's not a good practice as well, right? Okay, the release is coming, so let's just get it done. It means that you just skip on fixing the issues. You're pretty much focusing on the delivering the software, right? And probably if you remember one part of the quiz in the first few weeks, this is a kind of testing in production. Okay, we just release it, test with the customer. Whatever they found, we will fix it later. It's not a good practice. Let's think about this is a mobile banking application, right? You don't want this kind of thing happen because it is very expensive to fix. It costs the bad reputation to the companies as well. Mm-hmm. Yeah. So what is a technical debt actually? It is a metaphor. It's not the real debt. All right. It's a metaphor, not a theory, not a scientific concept. We just use the technical debt to indicate anything that is incompleted, immature, inadequate, right? But it's not just only the source code. All right. It can be something else as well. The design debt, testing debt, you need to test this one, but you skip it. Okay, forget about it for now. Let's release it. There's a test then. Okay, because you don't write the test case at the moment, but you want to test it later. Yeah, and it's just only the emphasize again. This is only the aspect. The metaphor is not the real thing. Okay, just a metaphor to indicate indicate something that is incompleted. It is immature and inadequate. All right. But is that so? That means there are pros and cons as well. Having technical debt, it doesn't mean that it is a bad thing. When you have lots of technical debt, it means that developers have a very high productivity, right? They don't need to fix everything. They just want to get it done and release it tomorrow, right? And the cost of the development is very low because you don't spend much of the time fixing the issues, right? But later on, right, it actually costs a lot in terms of the maintainability phase. Okay, in terms of the maintenance, when you want to maintain it, you need to pay it back, right? Because you need to pay the interest back. It increases the maintenance cost. You don't fix anything now, but later on, you need to come back and remind yourself, oh, what's wrong? What did we do? I do not remember everything because you don't document anything, right? That's the downside of the high technical debt. Okay, and it is quite risky as well because when you have like high technical debt, sometimes it gets out of control as well. Mm-hmm. Yeah, and as I mentioned before, the technical debt is not just only the source code, okay, but it can include the design debt, testing debt, documentation debt. For example, documentation debt. Okay, this is a new feature. This is a new algorithm. We already finished the implementation, but you skip the documentation. No one will understand. No one will know how does this code work. What is a pseudo code? That kind of thing, right? No one will understand it at all. Defect debt, you know the defect, but you don't fix it. You don't report it. You don't do anything. You know everything, but you don't do anything. That's a technical debt. Okay. All right. Okay. That's a technical debt. And for the maintainability issues, right? These are the code smell is one type of the maintainability issues as well. Okay. But based on the definition, right, is pretty much aligned or related to the object-oriented design. Okay. And yeah, there are lots of tools to detect the code smell. I will just give you an example, this one. Oh, wait. Okay. Yep. That's right. Okay, let's take a look at this example. All right, this is an example of the duplicate code. Let's try to look at it together. Yeah, how it is duplicated. First, print, good morning. How are you feeling? Okay, input the feeling. I'm happy to hear that you are feeling, yeah, feeling good, feeling better, that kind of thing. Good afternoon. Uh, and everything is the same, right? So these three lines, they are the same. How are you feeling? Input, I'm happy. How are you feeling? Input, I'm happy. What is that? What is the issue here? The code is duplicated. Let's say you receive a requirement to fix to change, update the what is that? The message here. Oh my goodness. You need to fix how many times? 3 times, right? It takes a lot of effort. Yeah, we need to work smart, not work hard at all, right? So that's why this kind of issue is called duplicated code. Okay, duplicate code is a problem because it makes changing the code very difficult. A change you make to one copy of the duplicate code must be made to every copy of it in the program. So if you forget something, the code will be wrong. I don't know whether you have such kind of experience in the assignment one or not. And I hope that you don't copy and paste, right? Okay, so how to fix this one, right? The solution to this, okay, if the code is duplicated, we just deduplicate it. Easy. So because this is repeated, probably we can put them in the loop, right? This is an example. Probably we can define a new method. Ask feeling. Okay, these are the three lines that is duplicated. Print, how are you feeling? Input the feeling and print. I am happy to hear that you are feeling something, right? But still, is this good enough? Okay, let's ask everyone here. Is this good enough or not? Probably not, right? Because some part is still duplicated. You have asked feeling 3 times, right? So can we write it better or not? Yes, we can. So we can put it into the for loop, right? For time of the day, in the morning, afternoon, or evening, and then we just call ask feeling only one time. For if you have duplicated code like this, oh dear, okay. If you have duplicated code like this, ask feeling. Let's say if you change the method name, what will happen? Oh, you have to change 4 times, right? The method declaration here and the method calling 3 times here. You need to change 4 times if you want to change the method name. So it's not a good practice at all, good coding practice. So that's why, yeah, writing this way is the best, right? And this is just an example of the duplicate code, okay? Just one type of the code smell. If you are interested, you can check more examples from this link as well. Okay, inventwithpython.com/beyond/chapter5.html. Okay, that's all for this week. We are talking about the code quality, technical debt, code smell. In the workshop, probably next week, okay, we will practice more as well, how to use this kind of tool to detect the code quality issues. And we're gonna evaluate as well whether your piece of code that you write before is of high quality or not, and what are the warnings that they alert, that they tell us that are detected, right? And then we will try to fix them together, okay? All right, any questions so far, everyone? Okay, in the meantime, maybe I will talk something about the week 8 a little bit, okay? Week 8 studio, all right? So this is the slide. Week 8, we have slide here. And then for the studio practices, oh no, I clicked the same link. For the studio practices, for this week, we will practice more about white box testing. Okay, so these are the reading materials that I highly recommend everyone to read. This is just to prepare yourself for the assignment 3. Okay, we will talk about what is the control flow testing, what is the statement coverage, what is the branch coverage, what is the condition coverage, what is the condition and the decision coverage, what is the MCDC, why do we need to draw the control flow graph, and what is the path coverage, how can we identify which path is feasible, is not feasible, how many test cases are required to achieve 100% path coverage, that kind of thing. The MACCAP, psychometric complexity, this is how we compute how complex is the code. This is a path coverage, okay? And dealing with exceptions, how to deal with it as well. And this is an example, studio exercise. This is what we are going to do this week together. This is to prepare yourself for the assignment 3, all right? So yeah, the topics that we will cover is are these 5 topics, okay? So we have, this is a Python program. So this is a Python program to compute whether this is a triangle or not. So we input A, B, and C, check the A, B, and C here, and returns the message whether it is a equilateral triangle, isos, what is that? Scales, triangles, or scalene triangles, or not a valid triangle, right? So with this test case, how many, what is the line coverage here? I recommend try to do it yourself. You don't need to do any coding. You don't need to use any computer. No, sorry. I mean, use any tools to support. You still need to use computer anyway. Yeah, identify what is the line of code. What is the branch coverage here? So you need to draw the decision tree, how many branches, compute what is the condition coverage with that test case, what is the minimum test cases to achieve the 100% condition coverage. If you focus on these 3 conditions, what are the test cases to achieve 100% CDC coverage, right? What about MCDC? Can you draw the control flow graph? If you want to draw using this one, okay, image annotator, use a canvas. So let's say you draw the program. Normally we use the, when you draw the control flow graph, there are 2 notations, the node, okay, the node with the line number and the age, okay? So let's say this is line number 3, draw the 2 branches. This is false, this is true, number 3, number 4, number 5, okay, false, true, and probably let me say 7, 6 here, 7, 8. This is an example of the control flow graph, okay? 8, 9, yeah, 10. This is an example. What is that? It means that there are how many decision branches? 3, 4, 5, 7. We have 4 decision branches. Easily, this is a 4 if else, okay? Yeah, 4 if else. Yeah, this is an example how to draw the control flow graph in the ED, okay, using the image annotation here, okay. Submit. This is not the right answer, okay? I just draw it randomly. How many feasible paths when you draw the control flow graph here? So the path can be 3, 8, 9, 10, 3, 4, 8, 9, 10, 3, 4, 5, 6, 8, 9, 10, 3, 4, 5, 7, 8, 9, 10. Yeah, that's a feasible path. How many test cases are required to achieve 100% path coverage? All right, so try to work on this one. Yeah, and see whether you can answer it correctly or not. Okay, so this is pretty much a focus for this week, advanced white box testing. And We have one question in the Zoom chat when the marks assigned for the assignment one. Okay, release will be released very soon, probably by the end of this week. We have finished marking already. We are finalizing it. Okay, all right, everyone. So everyone will know the mark very soon. And thank you so much for your attention. See you everyone in the studio. Yeah. Bye bye.